Hello everyone, welcome to solve this nice math Olympiad algebraic problem. And here we have a nice square which is inscribed with a semicircle and a right triangle. So here we denote the vertex of the square are A, B, C and D. So this is the vertex of this right triangle, and here we have this is the vertex of the square ABCD, and we have a triangle which is the one side of this triangle is tangent to this circle at this point, and we denote this point by E, and similarly we denote this point with F. So you have a triangle which is FBC, and its one leg is tangent to the circle at point E. So in the next step we use here the two tangent theorem. So now first I will little bit explain about the two tangent theorem. So you know that what is two tangent theorem. So in two tangent theorem we have two tangent segments are drawn to a circle from the same external point, then the segments are equal. So that here you focus on the right triangle, and here we denote the length of side FC with x. So we suppose that the length of the side FC equals to x. So we can write here the length of FC equals to x, and we have FEF. So we denote the length EF equals to y. So we write here the length EF equals to y. So you see that what is the length of CE, because here you see that the total length CF is x. So the length CE equals to x minus y. So this length from point C to E will be equals to x minus y. So now we use this two tangent theorem, and in according to the two tangent theorem, if we draw two tangents from the single vertex or single point, then the line segments are equal. So we have the point C, and in which we have two tangents. So one tangent is CD and the other tangent is CE. So the length of these two tangents are equal according to the two tangent theorem. So here we write as, because you see that the length of this side CD is 8, because ABCD be the square, so that the length of all its sides are 8. So we have the length of CD is 8, it is equals to the length of CE, it is x minus y, and we write it as x minus y equals to 8. So this implies that we find the value of x here, and we move this minus y to the right hand side, and we get x equals to 8 plus y. But here we denote that x equals to FC, because x be the total length of this segment FC. So we have this FC equals to 8 plus y. And now in the next step we again use here the two tangent theorem on this area. So here we have the point A, the point F and the point E. So if you see that the point in point F we have two line segments which is tangent to the circle. So the one tangent drawn from this point F is FA, and the other tangent is FE. So these are the two tangents. So these two tangents are equal according to the uh, two tangent theorem. So that here we write it in this form, because according to two tangent theorem the length of FA equals to length of FE, but length of FE is this length is y, so it means that the length of FA is also y. So it means that the AF or FA length will becomes y. And now you see here the total length a to b will be equals to 8, because this is the square and the one side length of square is 8, so all the other sides are also 8. So we have the total side length will be 8, but we have the side length of AF is y. So what is the side length of FB? So we easily see that this length will be equals to 8 minus y. So now here I draw the right triangle separately. You see here we have the right triangle CFB, and now we draw this triangle CFB here. So this is the right angle, and we have this point is B, this point is C, and this point is F. So if you see in the diagram, we have the longest leg is x, because our FC will be x. So we have this length is x, and our base is FB, and it is 8 minus y, because our 8 with the total length, but F to B length is 8 minus y. So we have this length is 8 minus y, and we have the length BC is 8, because this is the side of square, so this length is 8. And now we use here Pythagoras theorem, and we can easily find the values of x and y. So that here we use the Pythagoras theorem. So by Pythagoras theorem, we say that hypotenuse square equals to base square plus perpendicular square. So in this question we have the hypotenuse is the longest leg, it is denoted by x, and you see that we have the value of x is 8 plus y, so we use this value here, and our base is 8 minus y, and perpendicular length is 8. So we put these values here, and you get x square equals to b square. So our b is 8 minus y, so it will becomes 8 minus y square, and our perpendicular is 8 square. So here we put the value of x, and the value of x is 8 plus y, so we substitute here, and it will becomes 8 plus y square equals to 8 minus y square, plus the square of 8 will be 64. And now we open the square of this term, and we use the square identity, and you get a square plus b square plus 2 times of ab equals to a square plus b square minus 2 times of ab plus 64. So here you see that the this is plus y square and this is plus y square are cancelled by each other, and 64 are cancelled by this 64, and we have minus 16, and we move this minus 16 in the left hand side, and you get 16y plus 16y equals to 64. So you have 16y plus 16y will be equals to 32y equals to 64, and this implies that the value of y equals to 2. So this is the value of y, and now we move in the triangle, and here you see that if you have y equals to 2, so you get the value of 8 minus y. So here you put the value of y, it is 2, and 8 minus 2 equals to 6. So it means that the length of side FB is 6, because in this question we find, or we need to find the area of this triangle, and now we use the area formula, and here you see that the area of triangle equals to area of triangle FBC equals to half of the base multiplied by height. So you see that our base is 6, so it will becomes half of 6, and our height is 8. So now we cancel this term, and 2 3s are 6, and 3 8s are 24 units. So this is the our required answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.